Hi, and welcome to the last note-taking guide in our Family of Functions unit. I know this unit's been long, and I bet you're glad to be getting to the end of it. This video is going to be talking about inverse functions. And what an inverse function is, an inverse function is one that undoes another function, much like addition undoes subtraction, multiplication undoes division. Inverse functions use inverse operations to turn those inputs into outputs and outputs back into the original inputs. So an example, you're a construction worker and you work X number of hours a week. If the function answers, if you work X hours, you're going to make this much money, the input being the number of hours, the output being the amount of money. The inverse function is if the construction makes this much money, how many hours did he work? Now, if a function is modeled by the rule y equals 100x, then the inverse function is modeled by y equals x divided by 100. Since multiplication and division are inverse operations, they create inverse functions. I wanted to talk a little bit about the notation before we get into finding inverses. And the notation you'll see is f to the negative 1 is defined as the inverse function of f of x. I want you to know that this is not an exponent and is read the inverse function of x. So this is a very important rule, this next part. The inverse function of x is the inverse function of f of x if and only if we use composition of functions to evaluate f of the inverse of x and see if it's x, and vice versa. Use the inverse of f of x and see if that is also x. That sounds really confusing, I know. Lots of words in there, but when we put it into practice, not so bad. So let's check and see if f of x equals 3x minus 4 and g of x equals x plus 4 all divided by 3 are inverses. So we need to find the composition of f of g of x and then g of f of x and see what the result is. So I'm going to put f out and put that big parenthesis down, and then I've got 3, and I'm going to put a big parenthesis down, minus 4, and I'm going to substitute g. So I'm going to have f of x plus 4 divided by 3 equals 3 x plus 4 divided by 3 minus 4, and then simplify the right side of my equation. These 3's cancel, so I'm left x plus 4 minus 4. Well, that equals x. So far, so good. Now I'm going to go back and do it the other way. I'm going to put g of, and put out a parenthesis, and then I'm going to have my parenthesis plus 4 divided by 3, and I'm going to substitute in f of x, so I have g of 3x minus 4, then it will be 3x minus 4 plus 4 divided by 3. Simplifying the right side of my equation, So I have 3x minus 4 plus 4. That leaves my numerator as 3x divided by 3. So that one also results in x. So using my rule, if and only if the composition working both ways results in x, is this an inverse? Are these functions inverses? So are they? Absolutely. When we did the composition each way, the results were an x. Why don't you try example 2 on your own and see if they are inverses? Start the video up when you're ready to check your answer. All right, let's see how you did. We need to find f of g of x and g of f of x. So let's start with f, and that's just write this out, leaving a parenthesis where there's an x. Drop in x over 2 minus 5. Kind of looks like it, but there's a little trick here. Since the 5 is not divided by 2, I actually need to use the distributive property. So I'm going to have 2x divided by 2 minus 5. Oops, excuse me, made a mistake there. Let's start over. All right. I hate when I make a mistake, but it happens all the time. So I'm going to write this 2 back in here. So let's go back to using our distributive property. We have 2x over 2. 2 times negative 5 is negative 10 plus 5. So I have x minus 5. Going the other way, we're going to have g of substituting 2x plus 5 into my blank parentheses, and then simplifying. I'm going to have 2x over 2 plus 5 over 2 minus 5. I'm left with x minus 5 halves, if I did that correctly in my head. Neither one of those are x, so are they inverses? They are not. We had to have the results of both compositions result in x. I'd like you to do example 3 on your own at home and bring it with you when you come to class next time, and we'll check it out and see how we did. So how do we find these inverses if we're given a function? Remember, the inverse changes inputs and outputs around. Where we graph a number, we always represent the incoming number as x and the output number as y. To find inverses, there are 3 simple steps. First, replace that f of x with y. We've kind of been talking about that throughout the videos and throughout the year, that f of x and y are interchangeable. Replace f of x with y. Then switch x and y values and solve for y. Let's take a look at an example following these simple steps. All right, let's take a look at example 4. We have f of x equals 3x plus 4. Step 1 said replace that f of x with y, so y equals 3x plus 4. Next, switch x and y, so x equals 3y plus 4. And the last thing we have to do is solve for y. So I'm going to subtract 4 from both sides. So I have x minus 4 equals 3y y, then divide by 3 because I want to isolate my y, x minus 4 all over 3 would be the inverse function. So the inverse equals x minus 4 over 3. To check yourself, go ahead and do the composition of functions each way and make sure the result is x. So I'm going to have f of minus 1x. So that means I'm going to put the 3, big parenthesis, plus 4, and substitute in my values here. The 3's cancel since everything's divided by 3. So I have x minus 4 plus 4. Well, that one worked. I got x. Let's do the other way. The inverse and substitute my original in. So I'm going to have minus 4 all over 3. And I put 3x plus 4. And then I have 3x plus 4 minus 4, 0 divided by 3. Well, by George, we didn't make a mistake. They are both inverses of one another. Go ahead and try example 5. Remember to undo a square root. You are going to square to undo that. That's the opposite operation. Good luck on number 5. Start the video when you're ready. All right, let's see how you did. First thing we needed to do was change my g of x, or f of x, to y equals the square root of x plus 8. Switch x and y. X equals the square root of y plus 8. To undo that square root, I need to square both sides. So I have x squared equals y plus 8. Then I'm going to subtract 8 from both sides. X squared minus 8 equals y. So the inverse of the function g is x squared minus 8. And you could do that composition of function to check your answer and make sure they result in x. I'd like you to do example 6 on your own tonight. Bring that with you the next time we get to class and we'll check that answer as well. In addition, don't forget to do the self-check on the bottom of the page and print off your results and bring that with you as well to class next time we meet. We're going to work on those inverse excuse me, functions and finding them in more detail in class. Until then, have a great evening and we'll see you in algebra. Bye-bye.